Hey folks, problem number 5. Normal probability plot suggests the data come from a population that is normally distributed. So basically the minimum requirements are met. Right above that you can technically see what the minimum requirements are. Generally speaking, we want you to just get to the problem, so we usually say something like that. Okay. Construct and interpret a 95% confidence interval for the standard deviation of the following randomly sampled salmon lengths, round S to the thousandths place. Okay. So just read carefully. Do they want a confidence interval for sigma or sigma squared? It said 95% confidence interval for standard deviation. Okay. So they left out the word population, but it's implied. That's what you find a confidence interval for. So it said standard deviation. So that's just sigma. They didn't mention variance. They said for standard deviation. Okay. So I write down the formula. And now, instead of just straight up telling me the statistics, the summary statistics, they give me raw data. Okay, cool. So I'm just going to throw this into my calculator, get X bar, get S, and get N. And then I can just plug everything into here. Oh, I'm going to have to go to my chi-square table. But let's just do this first. So go to my calculator. Let's see, I need to put those numbers in a list. So that is, see, clear, stat, edit, enter. L1 has numbers, go up, hit clear, hit enter. 20, enter. 21, enter. 20, enter. 18, enter. 19, enter. 21, enter. 22, enter. 21, enter. 19, enter. Okay, so then I get stat, calc, one var stats, one variable stats, sounds good. I could tell it which list. It does L1 by default, so I'm just going to hit enter. Okay, X bar, 20.111. Oh, they don't even use X bar in this formula, so I didn't even need that. So you could just ignore that. S sub X, 1.269. It told me to round to the thousandths place. And sample size N was 9. So if N is 9, that means DF is 8, one less. So if I go to, let me sneak another piece of paper in here, DF 8, and they wanted 95% confidence. Okay, I'm going to draw my picture. 95 in the center. 5% left over, break it in half. 2.5%, 2.5%. So in order to get to this location and then this location, I had to go through 0.025. And to get here, I had to go through the 2.5 and the 95.975. So if I go to my chi-square table, picture should pop up in a second. DF8, okay, DF8, 025, 975. I see, 2.180 and 17.535. Okay, let me circle those, make it easy for me. So that's going to be 17.535 and 2.180. Those are my chi-squared values. Okay, we need to bring those back over here. So put the bigger one on bottom. Okie doke. 17.535. Smaller one, 2.180. Okay, n minus 1. 9 minus 1. 9 minus 1. S squared. 1.269 squared. I have to square it this time because it's just S. So careful. 1.269 squared. Sigma between these two values. Okay, we're almost there, folks. Just got to throw it into our calculator. Clear. 9 minus 1 is 8 times 1.269 squared, enter, divided by 17.535, enter. Now I got to square root that whole mess, square root that answer, slide out, enter, 0.857. They wanted me to round to the thousands. Okay, over here, let's hit clear. 9 minus 1 is 8 times 1.269 squared, enter, divided by 2.180, enter. Now square root that mess, square root that answer, previous answer, slide out, enter, 2.4309, 431, when rounded correctly to the thousands. And there is our 95% confidence interval for sigma. So technically, what does it mean? We are 95% confident the population standard deviation is between 0.857 and 2.431. Ta-da! Cool. Hope that made sense, folks. Homework should be pretty straightforward, just like all this. Have fun.